Good morning. Welcome back to the lecture on design for environment, where we're discussing life cycle assessment in the course Advanced Green Manufacturing Systems. I like to discuss the online tool EIO LCA in this lecture. Before that, I'll just like to show that in an economy, how does the product flow move. If you recall, this was the illustration that we discussed 2-3 lectures before, in which I showed you these returning circles in the purple color: circle 1, circle 2, circle 3 and circle 4. So if we look at them from the economy viewpoint, this is one way economy where the extraction happens and the resources, the production happens and industrial waste is there, and products are produced by manufacturers, the consumers use the products, these are consumers here, consumptions, and after that waste happens and finally the disposal happens. So the resource constraint is there. This is one thing. The resource always comes from the natural environment or ecosystem. This is one way economy. It always comes from here. Okay, and the final disposal is here, where is a lot of pollution happens. So these were the two major drawbacks of one way economy when we didn't recycle or reuse anything. But when we reuse, the more resource efficient economy is like this, which we had seen in this presentation as well. We reused, we remanufactured, we recycled. This is the same presentation. This is the same way of illustration given by ADB, Asian Development Bank. Okay, at first the extraction happens from natural environment itself and resources are there. So we reduce use of resources is because we can recycle, we can reuse, and these are the circles. I told you the other day as well, the smaller the circle is, smaller the circle implies more environment friendly. Right? Reuse is the first step, then we have recycle, then we have disposal. I also put those here. First is reuse, reduce after reuse, recycle comes here. So this is greenness or environment friendliness here. So the same thing is replicated here in this resource efficient economy, in which the separation of good happens. After the consumption, it goes to the waste treatment, and it also can be recycled. Metal parts can be recycled, oil etc. go to the lubricant treatment industry, where waste treatment happens, and finally smaller disposal or lesser pollution is there. But this is the thing that is desired at this point of time. But the ideal thing is the closed loop economy. In closed loop economy, there is a minimal extraction. You can see the width here is decreased in a way to present that extraction is minimal. Only it is the closed loop. It is between the production and the consumption and separation, the waste treatment is just moving in this direction again and again. It is a closed loop economy in this way. So in this case, the extraction from natural environment or ecosystem is very less. Okay, this is minimal, and pollution is also minimal. It is already written here: minimal extraction and minimal disposal. Okay, we are going to discuss the tool EIO LCA, Economic Input Output Life Cycle Assessment. There are two kinds of life cycle assessment. Those I will discuss. One is process based life cycle assessment, another one is economy based life cycle assessment, specifically EIO LCA that I have put here. Process based is when we are talking about the specific product, specific process, like manufacturing of this pen. What are the various components of the pen? Plastic, rubber, metal. Okay, these are only the three materials. Then ink, yeah, fourth material is there, fluid is there. Then what is this is the manufacturing of pen. What are the various industrial sectors? Those are considered in EIO LCA. I am talking about process based LCA actually. In process based LCA, we'll see what is the energy consumption, what is the pollution that is produced while manufacturing, etc. That we'll discuss when we'll see Gabi software. Okay, this we are discussing the EIOLCA tool. Where we are talking about the economy. This is economy level. So the results here in EIOLCA are economy wide and comprehensive assessment. It is not the specific assessment, it is a comprehensive assessment economy wide, or from the big system, or we also call it as SOS. As we are talking about advanced green manufacturing systems, a factory is a system, but a factory can also be called as system of systems. A system of systems means a factory has different units. It has additive manufacturing unit, it has machining unit, it has packaging unit. Packaging unit in itself is a system. So this system, small systems makes a big system, that is a system of systems. Now we are talking about economy. Economy means system of different systems where each small system is different factories, different sectors. Different sectors are mineral sectors, mineral oil sectors, agriculture sector. Then maybe in manufacturing we can have machinery manufacturing, computers manufacturing, semiconductors manufacturing, and wherever we think these are different systems which are brought into a big system that is known as SOS. This is system of systems. But in process based, the results are detailed and process specific. It can be process specific, it can even be product specific. But product also has some process associated with it. So let us first take the process based advantages only. It allows for specific product comparisons, like we can compare the pens, those are made from metal and plastic, and the pens which are made from only plastic. That we did the subjective study we did in value engineering. So this is the complete energy input database is there, and pollution that is produced, that all the databases are both these tools, one is the software tool, another is an online tool, are based upon the databases. These databases are provided by different companies, different economies, like EIOLCA is mainly developed by American institutions, and Canada, Spain, Germany has also put their data in to provide people to do some assessment on the different products. So those are the databases provided by the companies, that what is the total impact if I need to produce a pen, what is the total plastic that is produced, how would that impact different companies. For plastic, what is the total material that is extracted, what is the energy that is used in that, and all those are terms or presented in the terms of the money. In process based LCA, this identifies the areas for process improvements, weak point analysis. It provides for future product development assessment. The economy based or EIOLCA allows the system level comparison, which I just mentioned here, system of systems, use publicly available and reproducible results. Publicly available, this is an online tool which is publicly available. Only the thing is that we need to quote whatever they say here. This is also taken from the EIOLCA.net website. Right? So it provides for future product development assessment as well. It provides information on every commodity in the economy. Disadvantages are also there for both the kinds of the life cycle assessment. In process based life cycle assessment, setting system boundary is subjective. We do not know what is the system boundary, but we have to limit it to some extent. We need to tell that okay, this is only system boundary, we need to only work till the manufacturing or till the packaging or till the transportation to the customer, etc. So this tend to be time intensive and costly, because an engineer or a systems engineer had to work on this and work on the different databases or different inputs that to be given in. So this is difficult to apply to new process design in general. Use proprietary data, cannot be replicated if confidential data are used. Yes, uncertainty in data is also there. In EIOLCA, disadvantages are that product assessment contain aggregate data. The data is aggregated for the overall industry. For instance, I'm producing pens. It would take the plastic production. It can't differentiate between different kinds of plastic. Plastics can be polyvinyl chloride, PVC, bakelite, bakelite. Okay, bakelite cannot be used for producing pens. It can be nylon or certain other polymers, but aggregated data will just tell, okay, this is plastic, this is for plastic production. It can't differentiate between different kinds of plastics. In a similar way, it can't differentiate between the different kinds of the semiconductor devices maybe. So the process assessment is difficult in this because this is system data, must link monetary values with physical units. So these are monetary values with the physical units, and as I said, only monetary terms are given here, and the pollution is given in the emissions in the terms of the greenhouse gases. Now the imports which are there, those are treated here as products created within the economic boundaries. Now the availability of data for complete environmental effects is also a disadvantage. This is difficult to apply to an open economy with substantial non-comparable imports is very difficult. Uncertainty in data is there in both the cases because we are modeling, and as I said, this is kind of a simulating. With any model that is there, model is trying to simulate what is the real situation, and when we try to simulate or replicate the real situation, there are certain assumptions. EIO-LCA also has certain assumptions, and those assumptions bring in the uncertainties. So those uncertainties are here in both process-based and EIO-LCA tools. So now I like to take you to the online tool. So I'll type EIO-LCA, and the very first link is eiolca.net, that is there in Google. So it is giving the information about the EIO-LCA software, the economic input output life cycle assessment method, estimates the materials and energy resource required for the environmental emissions resulting from activities in our economy. The EIO-LCA method was theorized by and developed by economist Vasily Leontief in 1970s based on his earlier input-output work from the 1930s, for which he received the Nobel Prize in Economics. So this is some information that is given. This is a tool wherein the results from using EIO-LCA online tool provide guidance on relative impacts of different types of products, materials and services or industries with respect to resource use and emissions throughout the supply chain. So it is considering the whole supply chain. So thus the effect of producing an automobile would not only include the impacts at the final assembly facility, but also the impact from mining ores, making electronics parts, forming windows, etc. that are needed for the parts to build the car. So you can see we are taking automobile manufacturing for the final assembly. It is taking into consideration the extraction of ore, making of the components, making of the sub-assemblies. So it is taking all those components. So these EIO-LCA models available on the site may apply to EIO-LCA method to various national and state economies. Each model is comprised of national economic input-output models and publicly available resource use and emissions data. Since its inception in 1995, the method has been applied to economic models in United States, and now the countries like Canada, Germany, Spain, and select US states have provided the data, and the online tool has been assessed over 1 million times by the researchers, LCA practitioners, business users, students and others. So there is information on that. It is designed by Green Design Institute, Carnegie Mellon University. Okay, before coming to the tool, let me tell you what is the method. Okay, there are certain models which are available. These are the models which are developed. These are the 1997 PAW plus WW combined state. Different states have provided them, West Virginia, Pennsylvania, then 1992 model, then from 1992 onwards industry benchmark purchaser price and producer price models are coming into play. So 2002 has two models, purchaser price model and producer price models. As I told you, in the producer price model, only up till the manufacturing point is considered, that producer produced a good, what is the price that the producer has to pay. So the distribution or the transportation is not taken into consideration, but the customer has to pay the price when distribution is also taken into account. So that is the purchaser price model. So the producer price and purchaser price models are there. The recent model 2007 benchmark model is there. There are different models which have linked databases. How the models are different? There are different sectors associated with them. If I see this 2007 benchmark model, it has 388 sectors. So the effects which are available are greenhouse gases, energy, conventional air pollutants. It was last updated on 14th August. We will definitely use this model only. This is the most recent model. If you see, this is 388 sectors. The other models, 2002 producer price model, it has 428 sectors. More sectors are there and more effects are also available there. But the data might be a little outdated because this was last updated on 4th of July 2010. And this is most used model these days as well. 2002 benchmark model is being used, and there are previous models as well which have lesser number of sectors, and the data is also old. Okay, the number of sectors are higher here in 1997 industry benchmark model producer price. The effects are even more here, but this is again not updated. It was updated last on 4th July 2007. So we'll work on the 2007 model only. Before that, let us see how does this work. Now EIO-LCA works based upon this mathematical relation, where X direct is the direct output resulting from the entire economy, which is equal to I plus A into Y. What is I and A here? A is a matrix, I by J matrix. From the input-output accounts, the matrix or table A is created that represents the direct requirements of the intersectoral relationships. The rows of A indicate the amount of output from industry I required to produce $1 of output from industry J. So this is a matrix, I into J matrix, where A represents the amount of output from industry I that is required to produce $1 of output from industry J. This is a matrix we need to understand. You can definitely read about this information here. And this A into Y. What does this make? What is Y here? Y is the final demand vector. Final demand vector. Final demand vector of goods in the economy. Final demand in the economy, right? And A into Y makes the output produced in the all other sectors. Y is the final demand in the economy, which makes I into Y units of output to meet this demand, and A into Y units to produce outputs that are produced in all other sectors. Okay, so this is written in this way. So this is for a single sector, or this equation stands for a single tire. That is the demand of computers, means demands of computer, how would it affect the different sectors. Demand of computer, what is the pollution that is produced, what is the energy consumption that is used. But if you know the demand of computers would mean the demand of semiconductors or the components which are required to make the computers, that will also rise. This makes it two tire if we consider second tire. And for the demand of semiconductors, it might require to get the metals or the gold and silver which is used there, the demand of those metals. That can be two tire, three tire. Those are taken into account by making this model. X is equal to I plus A into AA. This makes it single tire. This is two tire. Computers and semiconductors. Okay, this is computers, semiconductors, and metals, and so on. So this makes it a mathematical relation like X is equal to 1 minus A inverse Y, or delta X is equal to 1 minus A inverse into delta Y. This is the mathematics behind the modeling that EIO is based upon. Now here RI is equal to total external output by XI. This XI we obtain from here. This is Xi that we get from this model. This model gives us Xi. Then Ri, what is Ri? Ri is the impact in sector I. Impact in sector I is the total external output by the total dollar input. The total external output would be then this Ri into Xi. So this total external output is not given as delta Bi is equal to Ri into delta X. So based upon this, the outputs are given. So let us start using the tool. There is the first page here, use the tool. I am clicking at this page, use the tool. So when I open this, the 5-step window opens, in which the first step is to choose a model. So there are three options: use standard models, create custom models, and documentation is also there. Okay, documentation is the information about that what are the kinds of models we needed to work on this. So, let us try to see the standard models. And this the 5-step window is here, in which these different sectors are given. So, 445 sectors for 92, these are again same sectors. So, I will select US 2007 with 338 sectors and producer model we will choose. Again we have the producer and purchaser models. These are purchaser models, purchaser price models, and these are the producer price models. I have told you the difference. So, let us pick this 2007 producer price model. When I select this, it will ask for the select industry and a sector. Which sector would you like to work on? I am trying to replicate the presentation which is given in the tutorial in this website only. They have taken a production of cars for which one car production would take $20,000, and for producing 100 cars it would take $2 million. So, the input is $2 million and we need to produce automobile. They have taken 2002 model, but I am picking 2007 model. So, our results would be a bit different from them. So, in this there are certain sectors here, or broad sector group here. Broad sector groups are like you can see agriculture, mining, construction, food, textile, wood, petroleum, resin, paint, plastic, all this. For automobiles, vehicles and other transport equipment is the one that we will select here. Now, select a detailed sector, they say. The detailed sector is automobile, right. So, for producing 100 cars with production cost of $20,000, we are going to set a demand to $2 million worth of automobiles. So, we have set the value 2 here, $2 million worth of automobiles. It is important to know that if we are analyzing a product that has a lower economic value, we might like to put a multiplier, because the results which are given in the 3 decimal places, 3 significant figures are there. So, if I put, for instance, I am taking the production of pen, I can't put 10 rupees, I need to multiply into such a big number, or I need to get a multiplier multiplied by 200,000 and so on. I have to use a multiplier so as I get the result in 3 significant figures of decimals. Other than that, the results won't be shown. So, $2 million is the value that is put here. Then we need to select a category, like we saw that conventional air pollution, greenhouse gases, energy were the 3 output or the results that we could see here. Let us try to see first the economic activity. Okay. For economic activity, the model can show results for a variety of impacts such as economic supply chain, energy use, environmental emissions, etc. for the economic activity, and for only conventional air pollutions it will. So, these are the inputs that we have given in. So, we need to have workable numbers. $2 million would give us the workable numbers. So, let us try to run the model and see what are they trying to tell here. Yes, we have run the model and we have seen that 10 input we can see here, we can even change the inputs. Total 10 inputs are displayed here, top 10 inputs are displayed. I have select conventional air pollutants here. Conventional air pollutants, it is showing the conventional air pollutants which are the mostly measurable or known pollutants conventional which are there. PM10 level, particulate matter 10, which is the all the sizes, all the particulate matter which are lesser than 10 microns of the diameter. It is giving the information here as well. This is the emission of particulate matter less than 10 microns of diameter to air from each sector. The value is primary. Okay. So, this T is small t is the units which is the metric tons. Okay. So, these are the pollutants for truck transport. In 2 million worth of the automobile that I am taking into account, the truck transport would produce 0.946 tons of carbon monoxide, 0.004 tons of ammonia, 0.538 tons of NOx and PM10, PM2.5 and so on. So, these are for top 10 sectors. I can even see all the sectors. Or let me first see economic activity. Select. I have changed the input from here, change input. have changed the input to on economic activity. Now, for all the sectors, automobiles worth $2 million and the direct economic impact for $2 million, it is in percentages here. It is showing that 0.318 million dollars worth wholesale trade would happen, the economic activity will be this, and 0.161 million dollars worth of direct economic purchases would be made. So, these direct economic effects represent the purchases made by industry being analyzed as opposed to the total supply chain effects defined above that include direct and all indirect purchases. So, this is in million dollars. This column below is the complete economic supply chain of purchases needed to produce your level of output. So, this is direct economic, this is direct in economic in percentages, direct economic effects representing the percentages made by the industry being analyzed. So, it is showing that $0.161 million worth trade is there, that is $161,000 worth wholesale trade is there. This is the economic activity, right. We can change inputs to greenhouse gases. Let us see that. Greenhouse gases. So, this is the total greenhouse gases would be 752 tons of greenhouse gases would be produced, of which carbon dioxide is 633 tons and methane is 9.97 tons, nitrogen oxide is 70.9 tons and other greenhouse gases is 37.8 tons. What are the various sectors which are affecting this greenhouse gases? Electricity is at the top. So, this is the amount of electricity 191 ton, this T represent a ton. Okay. Greenhouse gases global warming potential is the weighting of greenhouse gas emission into the air from the production of each sector. Weighting factors are 100-year global warming potential, that is GWP values from the IPCC 4th assessment report. So, these are the models which are taken databases from different sources and they have put the models in this common workplace or the website that we can see. We can see energy as well. So, this is energy, the total energy in terajoules, Tj is terajoules, total energy is 16.5 terajoules of energy is consumed in producing the cars worth $2 million, that is 100 cars, which of which one car is $20,000 million of worth producing. So, all that in coal, natural gas dry, natural gas liquid, crude, nuclear, biomass, hydro, solar, all these inputs are here, right. So, we can even see multiple or more than 10 outputs here, there are 25 outputs. I can even see all outputs here, all, select. If I see all, obviously the top 10 and top 25 does not changes, it is again the coal at the top, unrefined oil and gas at the second number. So, it is giving all the outputs now. So, we can even view graph and download here from here. View graph is like here. So, it is a pie chart that is obtained, it is giving the top 5 sectors with the colors. This is a dynamic chart in which when we go at the color, it will show that what is this sector, it is from coal and what is the amount, 45% is there and it is telling the value here, and all other sectors are here in grey color. So, we can see that the coal in red color and unrefined oil and gas in green color, these are the two main factors, two major sectors from which the energy is taken from in automobile manufacturing in United States. This is that model from that. Also, we can download the data. We can download the data in Excel sheet by clicking download here. But the data is being downloaded here. This data is downloaded. After downloading data, we can also interpret the result. We can make various other plots. Only pie chart is given here. We can make line diagrams or do certain statistical analysis or have the feel of the data. Data representation can be made in multiple ways when we have the Excel sheet with us. Okay, you can see that for the most of the sectors here, it is showing 0.0000. It might be negligible, like it might be 0.00001 something, but as it is showing results only up to 3 places of decimals, those results are not shown here. So, this is how we use the EIOLCA. Let me try to pick some other category now. In 2002 producer model, there is also an option to search for a keyword. For instance, I again need to work on computers. I can put COMP search. It will show all the possible outputs where COMP is used. COMP is in component, it is in computer, it is in compressor. Okay. So, there is a search option also there in this US 2002 model, and let us try to pick some other sector here. Let me try to pick maybe machinery and engines, and in machinery and engines I need to produce metal cutting or forming machine tools. Okay, in this case I would say I would like to produce machines which are worth $100 million of purchase, economic activity. It is also giving some details here. The sector is comprised of one or more NAICS sectors as described below: machine tool, metal cutting types, manufacturing. The US industry comprises establishments primarily engaged in manufacturing metal cutting machine tools except hand tools. So, it is showing these things. Run model for economic activity, it will show the results. So, economic activity is telling that okay, worth $212 million of total economic activity happens, of which metal cutting and forming machine tool manufacturing is the major contributor, and all are below it. So, we can do multiple assessments, life cycle assessments in this way, but this tool life cycle assessment EIOLC has certain limitations. Those limitations are mentioned here in the website only. They said that the factors that make EIOLC method an efficient and robust tool also limit its use for life cycle assessment. Though it is open source, publicly available, we can use it easily, but certain limitations are there. First, the results of an EIOLC and LCs represent the impacts from a change in demand from an industry sector. Depending on the model chosen, an industry sector represents a collection of several industry types, and this aggregation leads to uncertainty in how well a specific industry is modeled. As I mentioned before, this takes the aggregate data. In aggregate data, for instance, it has taken an example here. It has taken an example here. For example, in US models, one sector represents power generation and supply, which would include coal-fired plants with high levels of carbon dioxide and particulate emissions, as well as hydropower plants with virtually no carbon dioxide. It is just taking okay, hydropower plants there is no carbon dioxide, but for coal based plants there is a large amount of carbon dioxide. It is taking the average of that, which is not acceptable. Now, what we can do, if we know that we are using hydropower plants, we can change the emissions. If we know the emissions are significantly different than those are there in the data, we can change those and we can work on that. That can be done in the custom model. So, similarly, the second limitation is that as an LCA tool, EIOLCA models are incomplete in as much as limited number of environmental effects are included. The EIOLCA models use as the basis for data only which is publicly available, while industry specific data is publicly available for a number of environmental effects. We do not have the data for impacts such as habitat destruction, non-hazardous solid waste or non-toxic pollutants to water. In a way, they are telling that the data is not complete, it is somewhat incomplete, and certain other data sources have to be taken into account to complete the assessment. Some data used in earlier models, for example, fertilizers are no longer collected at the national level due to efforts to minimize reporting burden of companies. This is the limitation of the data. The first limitation is that the data is aggregate. First is data is aggregate. Second one is the data is not available for all the sectors, like only 488 sectors were available for this model. Then third one is this represents the results at the inventory stage of LCA. The results estimate the environmental emission or resource consumption associated with life cycle of an industry sector, but do not estimate the actual environmental or human health impacts that these emissions or consumption patterns cause. For example, US model estimate the emissions of particulates to air, but do not estimate the increased number of hospitalizations or deaths due to these emissions. Again, other sources and LCA methods will need to be consulted to account for translating the inventory results from an EIOLCA into impact on the environment. What essentially they are telling here? They are telling there are three limitations. These are not drawbacks, these are limitations. That means when we define the goal and scope, within that goal and scope there are certain limitations, the boundary within which this LCA works, the EIOLCA tool works. Now to deal with the inaccuracies in the data based upon the present schedule, if someone is more conversant with the specific data, you can use the custom model. In custom model, this starts from scratch, we choose the sectors, we keep adding the sectors and we can work on them. In hybrid model, we choose a sector to start with and we modify the inputs to create a hybrid model. So custom model, let us start from custom model or custom product. For a custom product, there are three choices here. They said okay, use a model. We choose a model here, then let me say I pick again machinery and engines. Detailed sector is cutting tool and machine tools, or let me pick some other one this time, rolling mill and other metalworking. Okay. So here I will select $500 million worth of the purchase of the machinery and engines. So we need to build the model and we need to keep adding these sectors here. We need to add this sector. The sector is added. Again we can add another sector. In machinery and engines only, we can select a specific sector other than rolling mill. Okay, let me pick what is the effect of special tool die, etc. So I said in this it is total $500 million. In this case I will say okay, let me say $50 million, add this sector. So we can keep adding the sectors here if we have the good amount of information about what are the exact values these sectors would contribute to them, and then we can build a model. Now it will consider these two sectors and build a model, right. So this is the custom based. In the same way we have hybrid product. In hybrid product we can choose a product, it has only two steps here. We choose a model and select a sector. Let me say again vehicles, or let me pick computers and audiovisual. Select a detailed sector. I need to have computer storage and manufacturing. Okay. What is the activity? Let me say $3 million. Select. Now when we select this, a page opens where we can change the activities here, change the values of the activities. If we know that in the production of the computers for $3 of worth purchase, this value 0.84 is quite big and we know that it should be lesser than 0.3, we can change it to like this. Okay. We can change some other value, like for instance if we know that stone mining and quarrying is not having big economic activity. So we can, if we know some value, a ballpark figure is there, we can put some value, like let me put it 0.25. Okay. Now we have changed the values. This is the hybrid model and we can now run it. Continue. So these are the updated results with the data that we have put in, and those are considered. So this is telling that your custom product is like this. In grain farming minus 474 weight is there, and stone and mining this much is reduced than the data which they have in the database. So this is the hybrid model. So we can interpret the results, we can have the custom made models, we can get the hybrid models. So EIOLCA data can be used in multiple ways to have the life cycle assessment of the economic activity or the activities, greenhouse gases, the conventional air pollutants and energy consumption and other toxic gases, etc. And different models can be used for getting the overall feel that how would the specific product manufacturing or specific sector affect my economy. So this life cycle assessment, this tool EIOLCA can be used in multiple ways, like when can compare different products or just have the feel of the data that what is coming, or we can just see for instance in the specific sector what is the impact that is coming. So overall feel of the data is there, and we can also, like in India, we know that what is the percentage of the electricity that is produced from coal, that is the thermal power plants, and what is the hydropower plants. That can be compared with some other model in US, what are the hydropower plants, what are the windmills, and how many percent, what is the percentage of thermal power plants, that can be compared. And for India and American model, we can compare. India and Canadian model can be compared, and we can have the data for India, and different comparisons can be made. So, this is one of the methods to have life cycle assessment, feel that what is the overall impact, or what is the overall energy, greenhouse gases, toxic gases, emissions, energy, or the economic activity. So, how does that work? So, this website has certain or a lot of information in it, like we have the tutorial here. I have also tried to replicate this tutorial that is presented here. This tutorial section is here. So, we have videos and written tutorial, we have the copyright information, the models and methods, different documentations. So, a lot of information is there, and we can access this tool. I would suggest you to pick some sector of your interest and try to see what is the total impact or environmental effect that is there in the product, or that would like to manufacture in future or work on in future for life cycle assessment. So, I will come with the next model, GABI software, GABI software, in which we will pick a specific product. For instance, we can pick specific manufacturer of a mouse, and we can see what are the various activities, what is the amount of plastic residue, what is the weight of different components, and what is the total energy consumption, what is total emissions. That is process based. We will come up with that in the next lecture. Thank you.